Rational inequalities. Our objective for this video lecture, we want to solve rational inequalities both graphically and algebraically. So in a previous video lecture, we solved polynomial inequalities. We're going to see many of the same methodologies here for solving rational inequalities. So this will look familiar for those who have already watched that video lecture. Okay, what do we talk about? What do we know that's going to play a part in this lecture, in this objective? We know what a rational function is. A rational function is the ratio of two polynomials. For example, f of x equals p of x divided by q of x, where p of x and q of x, the numerator and the denominator, are polynomial functions, and q of x, the denominator, is not the zero polynomial. We also want to recall from past video lectures that vertical asymptotes or holes occur when q of x equals 0. Okay? And the second thing we want to recall here, we want to remember, we know what an inequality is. An inequality is a statement involving two expressions separated by one of the inequality symbols, less than or equal to, greater than or equal to. Graphically, very similar to what you saw when we did polynomial functions. The steps are very much the same. Step 1, rearrange the inequality so that 0 is on the right side. So you're going to wind up with something like f of x is less than 0, f of x is less than or equal to 0, etc. Step 2, graph it. Okay? And locate the zeros, locate the x-intercepts, and locate the vertical asymptotes. Okay, those, remember, an asymptote bends. I probably should have put that up here in what we know. I forgot. An asymptote kind of bends the graph. It bends the curve. The graph doesn't touch your asymptotes. Step 3, between the zeros and the vertical asymptotes, f of x is either above the x-axis, meaning f of x is greater than 0, or it's below the x-axis, again, and meaning f of x is less than 0. And then finally, you include your zeros if your function is also equal to 0. So if you're dealing with this situation, f of x is less than or equal to 0, or you're dealing with this situation, f of x is greater than or equal to 0, we want to include our zeros in our solution set. Okay, let's do some solving graphically. I got that straight there. There is my rational inequality. This one says solve x minus 4 divided by x plus 2 greater than or equal to 2, and solve it graphically. So when is this greater than or equal to 2? Okay, well, step 1, we need to rearrange so the 0 is on the right. Okay, so I'm going to subtract 2 from both sides. So the left side becomes x minus 4 over x plus 2 minus 2 is greater than or equal to 0. Okay, so my 0 on the right. Okay, now let's make a note. Now we're going to graph. Okay, we're going to graph f of x is equal to x minus 4 over x plus 2 minus 2. What does that graph look like? Let's find our zeros and our asymptotes. Okay, get my calculator out. Let's see, I'm going to use my fraction bar, the numerator, x minus 4, the denominator, x plus 2, Then I'm going to subtract 2. Just in case, I'll set my window. I'm not sure where things are at the moment. Here it comes. Okay, there you have it. There's your graph. You can certainly see there's a vertical asymptote going on because it's bending the graph up to infinity and then coming down from infinity. Well, that takes place. We can kind of figure out where that is. We can say, okay, let's go to trace. It's either -1, -2, it's probably not -3. It's either -1 or -2. Let's check -1. Well, I got a value for -1, so that vertical asymptote is not -1. Let's check -2. Okay, I didn't get a value. Okay, so I have a vertical asymptote here at x equals -2. Okay, now where's the 0? Well, it looks like we're crossing the axis over here on the far left, but it's kind of hard to see. So I'm going to zoom into this far left and see what's going on. I'm going to do the window from -15 to -5. I don't need so much y. I'll go from -5 to 5 on the y-axis. Here comes the graph. And it's crossing right there is where it's crossing. So where is that? Second, calculate the 0. Left side, that looks good. Right bound, get to the other side of that. That looks good. Have the calculator figure it out for me. And the 0 is at -8, as you can see right here. Okay, so I'm going to go back to the standard window before I put it away. Okay, so I'm just going to have that fill it in. I have 2 things to be aware of. Okay, so let's see here. From the graph, okay, I have a 0, which is an x-intercept, of course, at -8, and I have a vertical, I'm going to abbreviate asymptote ASYM at -2. Okay, so here's my function. We want this thing to be greater than or equal to, so we're going to include the 0. We're not going to include the vertical asymptote, but we want to include the 0 because an equal sign here. But we want to be greater than 0. Okay, graph is greater than 0, which means it's above the x-axis. Okay, let's see here. Let's go back to my graph. Where is it greater than 0? Well, it's above the x-axis from -8 to -2, and that's it. This is entirely below the x-axis. It's below the x-axis before it hits -8, so from -8 to -2 is when it's above the x-axis. Okay, so between -8 and -2. Okay, so solution set is, now again, we want, because there's an equals here, we want to include the -8. So the -8 must be included, but a vertical asymptote it never touches, so we're not going to include the -2. Okay, it's not touching that. Correct. Okay, it's not, there's your answer right there. Okay, the graph is above the x-axis or equal to the x-axis, above, greater than or equal to, above or on, from at -8 and all the way up to -2, not including. Okay, let's solve algebraically. We're going to solve the same equation, the same inequality, excuse me. We're going to solve the same one. So we'll see how that works. Similar process again for those who have watched the polynomial inequalities video, the same idea, with a couple of small differences because it's rational. You're going to rearrange the inequality so that 0 is on the right. As necessary, rewrite the left side as a single quotient. That's different. We'll do that. Our example will include this. Okay, find the zeros, the x-intercepts, by solving the numerator equals to 0, because that's where your zeros are. Find the vertical asymptotes and the wholes by solving the denominator equals 0, because that's where your vertical asymptotes and your wholes are. And remember, we do all this with factoring, quadratic formula, etc. Okay, step 3. We're going to use the zeros and the vertical asymptotes and wholes. Okay, so in the polynomial functions, we only use the zeros because the functions were continuous. In rational functions, we got to factor in zeros, vertical asymptotes, and wholes to separate the real number line into intervals. Okay, and then the process is the same as we saw in polynomial inequalities. Select a number in each interval to evaluate the function at that number to determine whether the function is positive or negative over the interval you're evaluating. And then don't forget, include the zeros if we're talking about f of x is less than or equal to 0, or f of x is greater than or equal to 0. Okay? Let's do what we have here. Let's do that example that we just did, but let's do it algebraically. Okay, so here is that example. I think I got my paper. Okay, solve it algebraically. Okay, well, let's get 0 on the right. So I'm going to have x minus 4 over x plus 2 minus 2. That's a bad 2. Sorry about that. Greater than or equal to 0. Again, we want the 0 on the right. So solve it for 0. Okay. Now, notice that this is not one quotient. Okay, I need to, so part of this here, we need to rewrite the left side as necessary as a single quotient, one division problem, not a subtraction problem with more going on. So I need a common denominator. Okay, common denominator is going to be x plus 2. So the first one has, because this denominator is 1, so x minus 4 over x plus 2 minus 2 times x plus 2 over x plus 2, greater than or equal to 0. So now I wrote 2 over 1 with a common denominator of x plus 2. And obviously you can see here, the x plus 2 divided by x plus 2 is 1, and you go right back to here. Now I'm going to rewrite it as x, I'm going to rewrite it with one denominator, x plus 2, because I want a single quotient. This is minus 2 times x is minus 2x, and this is minus 2 times positive 2, which is minus 4. Okay, now let's clean up. So this is going to be a negative x minus 8 over x plus 2 greater than or equal to 0. So here I have my single quotient. Okay, I'll put over here, single quotient. You don't always have to do this. You have to do this if you have more than one thing on the left side when you have a 0 on the right. Okay, and let's also note here that now that I have a single quotient, f of x, this is the function I'm looking at. Negative x minus 8 over x plus 2. That's my function. Okay? So that first part is done. Let's find the zeros. Okay, so let's see here. Zeros from the numerator. Zeros come from the numerator. I'll tell you what, I'll do it this way. Zeros from the numerator. Okay? I have negative x minus 8 equals 0. If I add x to both sides, this tells me my 0 is x equals negative 8. Okay, my vertical asymptotes or wholes come from the denominator. Okay, so here's my denominator, x plus 2. When that is 0, I have a vertical asymptote or a whole, and I really don't care algebraically when I'm just looking about finding the solution set. I don't care if it's a whole or a vertical asymptote. It just tells me that I can't touch it. Okay, and this gives me that x is equal to -2. So that's either a vertical asymptote at -2 or a whole. Again, it doesn't bother me what it is at the moment. It doesn't bother me at all, actually. I just know that x equals -2 is a vertical asymptote, and -2 will not be part. It's a vertical asymptote or a whole, and -2 will not be part of the solution set. Okay, let's do the real number line. Okay, so make a number line. Here is my x at -8, and remember this is my 0. Okay, and here is -2. Remember, this is my vertical asymptote or a whole, and so no matter what, -2 is not included in my solution set. Okay, interval. Well, here, I have 3 intervals, less than -8, between -8 and -2, and greater than -2. So this interval goes from negative infinity. Now, is -8, is my 0 included? Yes, it is. Notice my original function has an equal sign, so the -8, 0 is included. Okay, the 0 is included because I have greater than or equal to. Okay, so again, the 0 of -8 is included, but the vertical asymptote or whole at -2 is not included. Okay, and then my final one goes from -2 up to positive infinity. Okay, let's find a test number in each interval. I'll do -10 in the first interval. I'll do -3 in the second interval, and all right, I get to use 0. I love using the number 0 as a test number when it's possible, and 0 is between -2 and infinity. Okay, we want to do f of the test number, which we want to find the function's value. Whoops, I'm almost out of my sheet here. Sorry about that. We want to find the function's value at the test number, so we want f of -10. And we also want to come up with our conclusion. Is it positive? Is the interval positive or negative? Well, f of -10, I've already put, here's my f function right here. Put -10 in here. This would be 2 over, this is 10 minus 2 over -8. This is -1/4. And so this interval is negative. Let's put -3 in here. What is f of -3? Well, that's 3 minus 8, which is, 3 minus 8 is -5, divided by -1. This is 5. And that's a positive interval, obviously, because it came out as positive. And let's put 0 into this third interval, the one furthest to the right. 0 goes in, I got -8 over +2, out comes -4, and so that interval is negative. Okay, so we know what our intervals do. We know that between -infinity and 8, we're below the x-axis because it's a negative. We know between -8 and -2, we're above the x-axis, and we know between -2 and positive infinity, we're below the x-axis. Okay, what do we want? Right here's what we wanted. Okay, this is what we solved for. That's what we wanted right here. Okay, we want our function, -x minus 8 divided by x plus 2 to be greater than or equal to 0. So we're looking for positive or equal to, okay? So our solution is this interval right here. negative 8. Remember, because it's equals, we're going to include the 0 all the way to negative 2, but because negative 2 is a vertical asymptote or a whole, we're not going to include it because it's not going to be part of the solution set. So here you have it from negative 8 to negative 2, including negative 8. Now remember, if we go back and graph this, this was the graph. And again, the positive goes from negative 8 to negative 2. It's equal. The function has an equal in it, so negative 8 is included. And in this case, you can clearly see that negative 2 is a vertical asymptote. So there you have it. How to solve a rational inequality both graphically and algebraically.